Since the beginning of the month, 6 dozen earthquakes have struck the Los Angeles Metropolitan Area, with this total including a magnitude 3.8 quake on March 2nd and a magnitude 4.1 quake on March 9th. Both of those earthquakes were felt across a large area and are currently continuing to produce near-daily aftershocks, many of which are being felt by local residents. So, what caused these earthquakes? Is there actually a sudden increase in these events, and is there any reason to worry? How seismically active is the Los Angeles area? Well, to answer the last question, the Los Angeles area is highly seismically active, with an average of 2.58 earthquakes of magnitude 0.4 or larger striking the area every day, although most of these are too small to be felt. These quakes can be owed to an ongoing nearby tectonic plate boundary where on the western portion of the San Andreas Fault, the Pacific Plate is sliding to the north-northwest, while on the eastern side of the San Andreas Fault, the North American Plate is sliding to the south-southeast. This causes quite logical strike-slip seismic activity when there are lengthy stretches of a fairly straight plate boundary. However, near Los Angeles, the problem arises because there is a notable bend in the San Andreas Fault. As a result, much of that overall plate motion in the region causes compression to occur, squeezing the area between the Palos Verdes Hills and the San Gabriel Mountains closer together at a rate of 0.2 inches a year. That may not sound like a lot, but across 15,000 years that compression adds up, totaling about 250 feet of compression. This motion is accommodated via the many earthquakes the region experiences, hence the abundant active fault lines in or near Los Angeles. That is why this very region during the last 15,000 years has produced 11 magnitude 7.0 to 7.5 earthquakes, along with a range of smaller earthquakes such as what we all just witnessed, in addition to earthquakes between these two magnitudes, such as the highly destructive magnitude 6.7 Northridge earthquake in 1994. With this in mind, I took the time to roughly model the average rate of magnitude 2.0 and higher earthquakes that strike in this highlighted area, so let's use this to see if the recent magnitude 3.8 and 4.1 quakes are truly unusual. A magnitude 3.8 earthquake strikes the Los Angeles area about once every 59.2 days, while a magnitude 4.1 quake strikes the area about once every 115.9 days. As for the earthquakes which occurred soon after, these marked aftershocks and are occurring at an expected rate, with the largest aftershock of either sequence when combined only being a magnitude 3.2. In other words, those two larger earthquakes felt by tens of thousands of people were not all that unusual or concerning. They were also both technically minor events, with the only damage being reported consisting of a few items falling off of shelves in some stores. While it can be difficult to determine which of the many regional fault lines produce these events, as there are also presumably many yet to be discovered smaller buried faults, I have an educated guess for the source of these two earthquakes and their aftershocks. But first, I want to note that due to the depth many regional quakes strike at, their epicenters oftentimes are not directly on the surface exposures of known fault lines. For the magnitude 3.8 earthquake near North Hollywood, a left lateral reverse fault known as the Verdugo Fault was the source. And for the magnitude 4.1 earthquake near Malibu, a more deeply dipping left lateral reverse fault which is unnamed was likely the source. Overall, there really isn't a notable increase in the rate of regional earthquakes, only a slight one, and that is owed purely to a combination of random chance and the expected aftershocks that follow the two larger earthquakes that struck. With the larger the main quake is, the greater the number of aftershocks there will generally be. I would not be too concerned, as the odds of these two smaller quakes triggering a larger damaging event is highly unlikely. As a final note, I would like to thank my new YouTube channel member Dave G for supporting my work.